Okay, today we're going to talk about the concepts behind related rates. Um, with related rates, you're talking about the change of variables with respect to other changes in variables. So the way we relate the rates of change of things. So this is about implicit differentiation with kind of in applications. Um, so this example here, it shows a cone of water, and basically it's dripping out the bottom. So what's happening is the cone is obviously losing height, as it's draining. You can see that height. And also, because it's the shape of a cone, you can see that the radius of the radius of the water, or of the cone, is actually changing as well. So we want to figure out how this all relates. Um, the first step to any of these problems is you need to identify all given quantities that you have and that you need to have. Um, and you want to make a sketch. Sketches always kind of help people visualize what it is they're talking about. Then you have to have an equation involving the variables that you need. If you're talking about, if you know the radius and the height and volume, then you need to relate radius, height, and volume together. Then you're going to implicitly differentiate, so you're going to do both sides. And the main thing is you're respecting time here. So with all these problems, we're respecting time as time passes. So any variable that you take the derivative of that is not time, you have to create its own special variable for it. And then after completing that, you substitute everything. So how is this going to actually look? So in our formula, so we're talking about how do we relate all these rates of change? Well, if I know that the height and the radius of a cone are related to the volume, and I find my volume equation, which is pi over 3 times r squared times height, then this is the equation I'm going to use to differentiate. So if I see v equals pi over 3 times r squared times height, I'm going to want to differentiate these with respect to time. Okay, so this is v to the first power. So the derivative of anything to the first power is just 1. But in this case, because I'm respecting time, I have to do dv over dt. So that's that side. We're finished. So now we have to do this other side. Now we have two functions here. We've got h and we have pi over 3 times r squared. So because there are two functions being multiplied together, I have to do the product rule, which is going to be the derivative of the first times the second plus the derivative of the second times the first. So we're going to do the derivative of the first function here, pi over 3 times r squared. So we're going to bring the 2 down, multiply by pi over 3. R takes 1 off of the exponent, so 2 minus 1, and then we multiply by our height. Or excuse me, we will multiply by also dr dt, which is the change of the radius with respect to time, because this is not time. Any variable that is not time in a related rate question, you have to add the d whatever variable over dt. Then we do the second part of the product rule, which says we do the second function. The derivative of the second function is just going to be dh dt multiplied by the first function, which is pi over 3 times r squared. So we just want to clean this up. So you can see here that we've got 2 pi over 3 times r times d, oops, I dropped my h over here, times dr dt times h, which I'm going to rewrite here, dr dt, and then I'm going to add onto that pi over 3 times r squared times dh dt. So while I reordered some of this, just make sure that when you're doing this, you're not dropping off any of your functions. Like the derivative of the first function is this entire part here, so it's like a massive chain rule. And then we add on our second function, we tack it onto the end, plus our derivative of our second function times the first. And then you always want to make sure you go through and simplify. Now this one, we have multiple variables, usually you're going to have only two, as opposed to this question having three, because that way you're normally not going to have quite all the information that you need. So you're going to have to relate one to the other. But all you really need to do is find the equation, differentiate it using implicit differentiation, and make sure that you're tacking on the extra part, the drdt's and the dhdt's, each time you take the derivative of a variable that is not time.